In my opinion, the hardest part about linear programming problems is setting them up. So before we begin, make sure you have this sheet in front of you, and please follow with me as I fill things out, because the hardest part about this is, again, setting up the linear programming problem. Go ahead and pause the video and take a moment to read through the problem. The first thing that I'm going to need to do is define what my variables are. And I have to decide in this problem, what am I producing? Because I'm not producing hours, I'm not producing labor, I am actually producing, in this case, bicycles. And so I see that I'm making the version called the Traveler and the version called the Tourister. I'm going to let X be whatever comes first. And so I notice that Travelers comes first. So I'm going to define X to be, and I want to be specific, number of travelers produced and then I can let Y stand for the number of touristers produced. Now, once I have my variables defined, now there's a couple other things I need to set up. And I'm going to use those variables X and Y for the rest of these, for the equation to be maximized or minimized, and for the constraints. If I look at the last sentence in italics, it says how many of each model should be produced to maximize revenue. So that means that I'm going to want to maximize something, and I want to maximize revenue. So let's try to set up my revenue equation. Revenue is different from profit in that revenue is the money that you're bringing in. Profit is the money you make after you pay for all your expenses. But revenue and profit both deal with money. So I'm going to look for money in the problem. And I notice that the Traveler sells for $200, which means you'll bring in $200 every time you sell one. And the Tourister sells for $600, so you'll bring in $600 every time you sell one of those. So my revenue is going to be $200 for each Traveler, which is X, plus $600 for each Tourister, which is Y. Now, the instant that I've used the 200 and the 600, I will never use those numbers again. The next thing I'm going to do is I'm going to write my constraints. There are two constraints that are very, very easy to write. We cannot make any negative bicycles. And so X has to be greater than or equal to 0, and Y has to be greater than or equal to 0, because it wouldn't make sense to make any negative bicycles. Now, it says each bicycle in the second sentence, each bicycle has the same frame and tires, but the assembly and painting time for the Traveler is only 1 hour, while it takes 3 hours for the Tourister. So assembly and painting time for the Traveler is 1 hour. It takes 3 hours for the Tourister. And there are 360 hours of labor available. So the things that I underlined in blue, the 1 hour and 3 hours and 360 hours, that goes together in a constraint. 1 hour for a Traveler, 1x. And 3 hours for a Tourister, so plus 3y. I can only use 360 hours or anything less, so less than or equal to 360. Let's try to set up the last one. There are 300 frames, and I think each bicycle, it says here, has the same frame and tires. So frame and tires, and you can assume frame and tires and frame means the same thing. So each bicycle has one set of one frame and one set of tires. So you got one frame for the Traveler and one frame for the Tourister, and I only have 300 frames available, so that means I could use less than or equal to 300. And these would be the constraints for this problem, and all of this together makes up one setup for a linear programming problem. Now let's do the setup for this second problem. Pause the video and take a moment to read through the problem. The first thing I'm going to have to do is define what my variables are, just like I did the last time. And my variables are going to be what I'm producing. So I am not producing time, and I am not producing hours. In this case, I am not producing oil, and I'm not producing vinegar either. I'm making salad dressing. And so I'm going to let X be whatever comes first, and I'll let Y be whatever comes second. So we are making garlic dressing and tofu dressing. I see garlic dressing comes first. Let's try to be specific. Number of gallons of garlic dressing. And then in this case, Y is going to be the number of gallons of tofu dressing. All right, the next thing I need to do is set up my equation that I want to maximize or minimize. We want to maximize the profit. So I want to maximize profit. So in order to write my profit equation, I have to look through my word problem and find keywords like profit. I see it right here, $3 profit on a gallon of garlic dressing, $2 profit on a gallon of tofu dressing. Those are the numbers that I need. Profit is going to be equal to 3x plus 2y. I am never going to use the 3 and the 2 again. Now, the next thing I need to set up are my constraints. There's going to be 4 of them in this case, and 2 of them are very easy. I can't make any negative gallons of dressing. So x is going to be greater than or equal to 0, and y is going to be greater than or equal to 0. Just like it was in the last one. Now, let's look at other things that are going to limit what I can do. I see that each gallon of garlic dressing requires 2 quarts of oil. Each gallon of tofu dressing requires 3 quarts of oil. And we have 18 quarts of oil. So the 3 things that I underlined in blue, oil, oil, and oil, those go together. 2 quarts of oil for garlic dressing, so that's going to be 2x. 3 quarts of oil for tofu dressing, so plus 3y. And I got 18 quarts of oil total, so it needs to be less than or equal to 18. Let's set up the last constraint. That's going to deal with vinegar. I see that garlic dressing requires 2 quarts of vinegar, and I see that tofu dressing requires 1 quart of vinegar. And I see that we have 10 quarts of vinegar. So the 3 things that I put squares around or rectangles around deal with vinegar. So let's put those together. 2 quarts of vinegar for garlic dressing, so that's 2x. 1 quart of vinegar for tofu dressing, 1y. And we have 10 quarts available, so less than or equal to 10. So all of this, defining variables, writing our profit equation, and setting up our constraints, constitutes setting up a linear programming problem. On this page, what we are going to do is solve one linear programming problem completely from start to finish. Please take a moment to pause the video and read through the problem. We need to define what x and y stand for, and x and y are going to deal with what we are producing. And I'm going to let x be whatever we produce, whatever I see first. And I see tomatoes first and green beans second. Now, x is not the number of tomatoes and y is not the number of green beans. X is going to be the number of bushels of tomatoes and y is going to be the number of bushels of green beans. The next thing I need to do is determine the equation for what needs to be maximized or minimized. The statement in bold says how many bushels of each type should she grow to maximize her profit. Obviously, we want to maximize profit. And I have to look through the word problem and find key words like profit. So she makes $1 profit on each bushel of tomatoes and $4 profit on each bushel of green beans. That's going to be my profit equation. 1x plus 4y. Now, let's come up with the other constraints. And it says in the directions there's going to be 4 of them. First of all, I can't make any negative tomatoes or negative green beans. So 2 of them are very easy. X is greater than or equal to 0, and y is greater than or equal to 0. Those are the 2 easy ones. Now, the other one deals with other things that are going to limit what I can do. And the things that are going to limit what I can do is how much money I have in the budget and how many square yards of land I have available. So we got 2 different things with money. We got profit, and we have how much it costs. Let's deal with the money one first. It costs $3 to grow a bushel of green beans. It costs $1 to grow a bushel of tomatoes. I did that a little bit backwards, but that's okay. Veg's budget is $15. So those 3 things that deal with money need to go together. And it's going to be 1x plus 3y has to be less than or equal to 15. Now, the thing that deals with square yards of land takes 1 square yard of land for tomatoes, 6 square yards of land for green beans, and we have 24 square yards of land available. So those 3 things go together. 1 square yard of land for tomatoes, 1x, 6 square yards of land for green beans, 6y, less than or equal to 24. Now is my next step, since I'm going to need to graph these constraints. Remember, these first 2 constraints are very, very easy to graph. X is greater than or equal to 0, and y is greater than or equal to 0 in the first quadrant. And so that's the upper right-hand corner, which is basically all that I have anyway. So I have already graphed those 2 just by the way the graph is drawn in. For these other ones, I need to make an XY table, and I need to figure out what the intercepts are. So remember, we make an XY table, let x equal 0 once, let y equal 0 once. Plug 0 in for x, so cover the x up with your thumb. We'd be left with 3y equals 15. 3 times 5 is 15. If I plug 0 in for y, the 3y term is gone, so cover that up with your thumb, and I'd be left with an x and a 15. I'm going to do exactly the same thing for this other inequality. Make an xy table, let x equal 0 once, and let y equal 0 once. If x is 0, the x term is gone. Cover it up with your thumb. You'll be left with 6y equals 24. So that means y would need to be 4. If I plug in 0 for y, the 6y term is gone, so cover that up. And I'd be left with x equals 24. So those would be my x and y intercepts for those 2 constraints. The next step that I need to do is graph what I just figured out in the table. Graph those points from the table. So I'm going to plot the point 0, 5. And let's just estimate where 0, 5 is. I'm going to estimate it to be about right here. Make sure you label stuff as you graph it. So that's the coordinate 0, 5. Then I got to do 15, 0. So I want to try to keep my scale consistent, and so I guess 15, 0 might be about out here. So let's label that 15, 0. My inequality symbol has the equal to in it, so I'm going to draw on a solid boundary line. I'm only interested in what's in the first quadrant. That's why I didn't draw it super long. I really just connected those 2 dots. And then I'm going to have to decide where to shade. I can't just simply look at the inequality symbol because it's not in slope-intercept form. But if I put it in slope-intercept form, the inequality symbol would still be less than or equal to. So I'm going to shade underneath this line. I'm not going to do it yet, though. Let's graph the other line. So I'm going to plot the point 0, 4, which is going to be about where 0, 5 is, a little less. Again, label stuff as you do it. So there's 0, 4. And then I have to plot the point 24, 0, which is going to be out past 15, 0. So 24, 0. I'm going to connect these with a solid line because it said less than or equal to. And then I need to decide where to shade for this one. It's going to turn out that I'm going to shade underneath this one also. So I'm shading underneath both of these lines and in the first quadrant. So here's my shaded area. So now the next thing that I'm going to need to do is figure out what my corner points are. In order to figure out what our corner points are, let's take a look at what I have. 0, 4 and 0, 5. 0, 4 is on the boundary of the shaded region, so 0, 4 is a corner point. 15, 0 and 24, 0. 15, 0 is on the boundary of the shaded region, so that's a corner point. 0, 0 is in the lower left-hand corner here. This one is also a corner point, and I don't have to do any work for that. So I found 3 already. Here's my fourth one, and I'm going to have to do a little bit of work to solve this one. So let's take a look at my 2 inequalities that I graphed. I am now going to make those equations because I don't need the inequality symbol anymore. I've already drawn the line and I've already shaded. So I'm going to have x plus 3y equals 15, and I'm going to have x plus 6y equals 24. I'm going to have to solve this using the elimination method or the substitution method. If I choose to eliminate the x's, I'm going to multiply one of the equations by -1. If I want to eliminate the y's, I'd have to multiply the top equation by -2. I'm going to choose to multiply the bottom equation by -1 just because. So here's my system of equations that I'm going to solve. X plus 3y equals 15. That one stays the same. The bottom equation is now -x minus 6y equals -24. Adding these two equations together, I would get -3y equals -9. And then if I divide both sides by -3, y is going to be equal to 3. Almost finished. Let's plug y equals 3 back into one of those two equations. I'm going to plug it into the top one just because. So if I plug it into the top one, I'm going to have x plus 3 times 3 equals 15. So I'm going to have x plus 9 equals 15. And if I subtract 9 from both sides, x is going to be equal to 6. So my missing corner point is going to be the coordinate 6, 3. And I'm going to use that fourth corner point in the last section. Let's test each one of these corner points to see which one maximizes our profit equation. I'm going to write down my corner points over here on the left-hand side. 0, 0 was one of them. 0, 4. 6, 3 was the one I just calculated. And then 15, 0 was the other one. Let's plug all of this stuff into my profit equation, which is at the top. So my profit equation is x plus 4y. In this case, I'm going to have 0 plus 4 times 0. In this next case, I'm going to have 0 plus 4 times 4. For the next one, I would have 6 plus 4 times 3. And for the last one, I would have 15 plus 4 times 0. Let's figure out what these answers are. First one, 0. That's easy. Second one looks like that answer's 16. The third one would be 6 plus 12, which is 18. And then the last one would be 15. So now I just need to decide, hey, which one of these numbers is the biggest? And it matches with this one. So what I'd like to do is write a conclusion statement for this problem. The 6 stands for something, the 3 stands for something, and the 18 stands for something. We plugged everything into the profit equation, so the 18 is profit. So, in order to make $18, which is our profit, veg should grow 6 bushels of tomatoes, and 3 bushels of green beans. With that conclusion, we have done one linear programming problem completely from start to finish.